In this video, we'll cover stochastic gradient descent in PyTorch. First, we'll cover it the conventional way using tensors, and then we'll cover it using the data loader object. We'll repeat the process we did before by creating some tensors of simulated data. We'll define the forward function with two parameters. This is essentially the equation on the line. And we'll define our criterion function. When this function only has an input tensor with one sample, it will produce the following result. There's just a difference between our estimated point and our actual point. Just a little note, this line of code is included in the lab, and this will calculate the true loss. This is not always possible in real applications, as we may not be able to fit all the data onto one computer. So as before, we run through multiple epochs in this loop. And we'll also plot out the data space iterations, where the red points represent the training samples, and the blue point represents the actual generated line using the parameter values at that particular iteration. We'll also plot out the loss or total cost surface contours, and this will be our initial value. So for the first epoch, we run through the first nested loop. We perform the update step using the first sample, then the second sample. We'll continue the process until we use all the samples. We can see that data space that the line has changed accordingly. If we look at the lost surface contours after all the iterations, we see the parameter value has changed. It started off in this point and has ended off on this point. For the second epoch, we run through the first nested loop again. We use our first sample, second sample. That's how we used all the samples. Our data space line changes, becoming closer, and our loss surface also changes. We've now run 120 iterations. We repeat this process for the third epoch. We run through the first nested loop, using all the data. The line in the data space gets extremely close to the sample point, and the parameters are approaching the minimum of the total loss or cost surface. And for the final epoch, we repeat the process. The line gets extremely close to the data points, and we approach the minimum of the cost or total loss surface. Now we'll perform stochastic gradient descent using the data loader. We'll create a data loader class, and this basically creates our simulated data in the constructor. We'll create a dataset object as follows. And just a little note that's not widely used in PyTorch documentation, we can get access to our dataset by using the attribute .x and .y, and this will give us some access to our entire dataset. This may not always be possible if your dataset's very large. Once we've created the dataset object, we use it as an input to our data loader constructor to create our train loader object. It's helpful to think of the train loader as an object that takes the dataset as an input, and in this case, we set the batch size equal to 1. The only thing that's really changed is the following line of code. Let's split it up. And we see we've replaced, instead of extracting our data from the tensors x and y, we extract our data from the training loader. And that's it. So if you look at the loss for every epoch of stochastic gradient descent, you see in this case that the loss is still higher for a higher number of iterations. And just one final note, you can also plot stochastic gradient descent for every iteration as well. And that will be an exercise in the lab.